Alright, so this is kind of the part 2 of the energy video. We didn't quite get finished the first time, so there's a couple of more practice problems that we're going to look at. Alright, so number 5. There is a 1200 kilogram, so 1200 kilogram, that is mass, so we know the mass is 1200 kilograms, automobile, and it is traveling at a velocity of 100 meters per second. So we know that the velocity is 100 meters per second. Is the energy potential or kinetic energy? And then how much energy does it possess? Okay, well first, the automobile is moving. So would that make it potential or kinetic? Alright, I'm hoping that everyone said kinetic energy because it is moving. Alright, so we're going to be solving for kinetic energy because it is moving. So, kinetic energy. We know that the formula for kinetic energy is 1/2 mass times velocity squared. Now we can plug in. So Ke equals 1/2. We know that the mass was 1200. We know that the velocity was 100. And remember, we are going to square only the velocity. So 100 squared, not the entire thing. Alright, we are now going to simplify. Alright, so if my calculator is correct, 1/2 times 1200 times 100 squared, so 100 times 100, it should be 6 with 6 zeros. So that is 6 million. And again, it is joules because we're solving for energy. So the car, the automobile, has 6 million joules of energy, which makes sense because it is going pretty fast and it has a lot of mass. Alright, number 6. Someone is holding a tennis ball outside of a second floor window. So, Bjorn is holding a ball. So holding a tennis ball. We know that his second floor window is 3.5 meters from the ground. So the height is 3.5 meters. And he's holding a ball, so we gotta figure out the mass of that ball. Billie Jean, so Billie is also holding one outside of a third floor window. So third floor, a little bit higher up. So now Billie Jean has a height of 6.25 meters. How much more? Ooh, how much more? So that means we're going to need to know which one's greater and how much more is greater. So a little bit of subtracting going on. Gravitational potential energy. Does Billie Jean's tennis ball have? So we know that Billie Jean has a greater amount of GPE, but we want to know how much more. Alright, and we are given that each tennis ball has a mass of 0.06 kilograms. So 0.06 kilograms. 0.06 kilograms, the mass of both balls. So we're looking for GPE, the potential energy due to gravity. So GPE equals mass times gravity times height. Use the same equation for both sides because we're looking for GPE for both, mass times gravity times height. Alright, then we're going to plug in. So, the GPE for the ball in the second floor window, the mass is 0.06. The gravity will go with 10, 9.8, 10. Either way you do it, it'd be really close. The height is 3.5. Alright, on the other side, if we set up Billie Jean's equation and we can substitute the mass, again, same size tennis ball, 0.06, same gravity, they're both on Earth, so 10. And then the height, Billie Jean is higher up, she's a floor higher, so it's going to be 6.25. Alright, now use your handy dandy calculators to calculate what the gravitational energy for both is. So our first ball on this second floor window should be 2.1 joules. Alright, and Billie Jean's ball should have a potential energy, gravitational potential energy of 3.75. So we knew that Billie Jean's was going to be a greater potential energy because she is higher up. And the more height you have, the more potential energy you have. So Billie Jean has 3.75, and Bjorn's ball is that's a 2.1. So we need to know how much more GPE does Billie Jean's tennis ball have. So 3.5 minus 2.1 equals, all right, and if you use your calculators, you should get 1.65. And we're still talking about energy, so joules. We know that Billie Jean's tennis ball has 1.65 more joules of energy because it is higher up, a whole story up. All right, number 7. A 15-kilogram bicycle is carrying a 50-kilogram boy, and they are traveling at a speed of 5 meters per second. What is the kinetic energy? Kinetic energy, because yeah, they are moving, they're traveling, they have some sort of motion, of the bicycle and the boy. So bicycle and the boy. So what we're going to need to do first is figure out their mass, because we're looking for kinetic energy, right? Remember, our formula for kinetic energy is 1/2 mass times velocity squared. We know the velocity was 5, so we could plug that in, but we don't know the masses quite yet of both the bicycle and the boy. So we're going to need to figure that out first. So the mass of the bicycle and the boy is going to be 15 plus 50. So the mass of both of them combined should be 65 kilograms. All right, and it told us that the speed or the velocity, same thing for these problems, is 5 meters per second. So now we can substitute. We can plug in everything that we have and we should get the answer. So kinetic energy equals 1/2 mass, well, the mass of both the bicycle, remember both the bicycle and the boy, we found to be 65. So we're going to plug in 65 times the velocity, and the velocity was 5. And remember that velocity is squared, but only the velocity is squared. So we should have KE equals 1/2 times 65 times 5 squared. All right, and remember to be careful as you type these into your calculator. You only want to square the 5, not the entire thing. So maybe do the squared part first. So 5 times 5, 25. Then multiply that by 65, and then half it. So you should be getting 812.5. And again, we're talking about kinetic energy, so joules. Energy is measured in joules. All right, very good. Last part. We have a little bit of a roller coaster scenario. We have a Hot Wheels car. This car, it says at the very top, is 0.1 kilograms. So keep in mind that the mass is 0.1 kilograms. Super important. And the car and the driver are shown at different points along a Hot Wheels track. Fill in the blanks at each point. Be sure to include units. Consider the system to be frictionless. So we're saying that it's frictionless. That means it's an isolated or a closed system. We're not taking into account friction because remember, friction can create heat. So just like whenever you rub your hands together, you're creating friction and that warms up your hands, you'd be creating heat. So we're not going to worry about heat quite yet. All right, so our first position, the little Hot Wheels car and the driver are at the very top at point A. See the little card here. All right, so it gives us that the potential energy, and remember potential energy is mass times gravity times height. They tell us that the potential energy is 2.9 joules of energy. All right, it gives us the kinetic energy. It says it's 0. And it even goes to say that the velocity is 0. So this car is just sitting here. It is not moving. It has no kinetic energy because it's not moving. We have to figure out what the height is. So how far up is this car? We want to know the height. All right, so before we get started, I do want to remind you that energy is never created or destroyed, but it can be transferred. So that means for every position of the car, we should have the same amount of energy. Maybe not the same amount of potential and the same amount of kinetic, but the total amount of energy. So because at point A, we have potential and kinetic energy, if we were to add these together, we're going to get 2.94, right? 2.94 plus 0. So that means that at every position, we should have 2.94 joules of energy. It's always going to be that total amount of energy. It can be converted back and forth between potential and kinetic, but remember, we're not adding or removing any energy from that system. It should always be 2.94. So for point A, we are looking at how high that car is. So we know the potential energy is 2.94. We know the mass of the car was 0.1, right? And gravity is always going to be 9.8, or for our case, we're going to be using 10. So we know that the potential energy is found by using mass times gravity times height. We can plug in exactly what we know and figure out what height is, because we have all of those variables except for height. How easy is that? So we know that the potential energy is 2.94. So 2.94 equals, well, the mass we said was 0.1. 0.1. The gravity is 10, and we are looking for height. All right, so that means 0.1 times 10. We need to simplify. So 2.94 equals, and then we need to do 0.1 times 10. 1 times 10 is going to be 1, and then times height. All right, so essentially your height has to be 2.94. So your height is 2.94 meters. So that means up here we can write 2.94. All right, so we have box A complete. Remember, height is in meters. All right, now at point B. At point B, the car is down here. So we're looking down here at point B. The car is moving. It has moved down this ramp all the way to this position. All right, so the height is 0. It's on the ground. Check, got that. We want to know the potential energy and the kinetic energy and the velocity. Wow, how are we going to figure that out? Well, let's start with potential energy. So we know that potential energy, again, is calculated by this formula up here. Mass times gravity times height. All right, if there's no height, if you plug in a 0 where this h is, the whole thing's going to be 0. So we have no potential energy here because we have no height for this car. Well, that was easy. 0. All right. And again, we said that for every position that this car is, the total amount of energy should be 2.94. That's the amount of energy that we started with. That's the amount of energy we're going to end this scenario with. So our kinetic energy has to be 2.94 because we don't have any potential energy. So all the energy must be kinetic. So 2.94. All right, there you go. No math, just concepts. Now we do need to calculate the velocity. All right, so to calculate the velocity, we're going to do a little bit of math. So we know the kinetic energy. That's super important. So kinetic energy, we know the formula for kinetic energy is 1/2 mass times velocity squared. We're going to be solving for velocity. It's squared, so we're going to have to get velocity on a side by itself eventually and do a square root, all that fun stuff. So we know our kinetic energy is 2.94, so we're going to plug that in, equals 1/2. And then we know our mass of our car, it's the same car, 0.1. 0.1, and then we're looking for the velocity squared. All right, so we do need to simplify. So to simplify, we should have 2.94 equals, well, 1/2 times 0.1 is going to be 0.05, and then velocity squared. We need to continue simplifying. We need to be on a side by itself. So right now it's being multiplied by 0.05. We need to divide by 0.05 on both sides. On our right-hand side, this cancels out. When we simplify, 2.94 divided by 0.05 is 58.8 equals velocity squared. All right, we haven't found the velocity yet because we do need to take the square root. We want just the velocity. So, to find just the